Hello everyone. In this video, we will be having a look at three piecewise functions. So these functions are a type of functions which have different values or different equations or formulas at different intervals. Like it will have different values or equation at this till this interval. Then again it will have different graph for this interval, and then again it will have different graph for this entire interval till positive infinity. So these are piecewise functions, and the interval where this graph ends, this point, may come in this interval or may come in this interval, depends on the type of brackets the intervals are having. These are closed and these are enclosed or open brackets. Open, closed brackets. So let's more discussion about these functions. So say f of x is equals to x square and 1 minus x. X is less than 0. X is greater than or equal to 0. So these values are like minus 1, minus 0.5, minus 2, and so on. And these values are starting from 0, including 0, 1, 1.5, 2 till positive infinity. So let's see how this graph looks like for this function. So here we'll start with x squared. So when we are dealing with x squared, we will assume f of x equals to x squared. We'll assume it as a single function, x squared, and take values less than 0. So we'll take minus 1, minus 2, minus 3, and here it will 1, 2, and so on. So we know since it is squared, the values will be always positive. So f of x, that is here, or y, will always be above the x-axis like this. Alright? But remember, here 0 does not belong to this interval, it belongs to this interval or this equation. So we will exclude it by like this, by putting a circle like this. Right? Now let's see what does 1 minus x graph looks like. So here we will be including 0 in this interval, and the graph will look like something like this. It will start from 1, and when x is 1, then the y of f of x or y is 0 when x equals to 1. So it will go like this, right? Here we go, and we're gonna put a dot on the y-axis where this interval ends. We're gonna put a dot. This dot resembles that 1, 0 comma 1 is in f of x with the interval 1 minus x. So this is the concept of intervals, and here the range for f of x is minus infinity to positive infinity. and domain is also the same, infinity to positive infinity, right? So this is just a complex function with two simplified or two sub functions, right? First function is x squared, second is 1 minus x. Let's do another example of this scenario or piecewise functions. Let's draw the graph of function f of x equals to absolute value of x. Here we know this thing will always be positive, right? Because it has absolute value, it is an absolute value. So the condition for this function is x is positive if x is greater than or equal to 0 and x is negative, right, if x is less than 0. These values include minus 0.5, minus 0.001. It is minus here because absolute value can never be negative, can never be equal to negative. So to make it positive, we need to add a negative over here. So if say x equals to minus 2, so minus of minus 2 will be positive 2. Let's draw a graph of this function mod of x. Here we go. So let's assume this thing for this part first. So here notice that it can be greater than or equal to 0. So this means this interval includes 0. So we're gonna put a dot, not an open circle. So here it will be like this with slope 1, and here, and in the second case, minus of x is less than 0. It will be going upwards, or mod x or f of x will be always positive because it is absolute value even if x is negative. So imagine we taking the value of x equals to minus 1. Here the value will be the mirror image of this line y of y equals to x in the negative x direction, like this. So this is minus x and this is x, and adding these both we get this function absolute value of x. So I hope these piecewise functions are clear to you guys. In the next topic, in the next video, we'll discuss about increasing and decreasing functions. And thank you for watching this video.